Hello everybody and welcome to Oblique Planes 9. In this tutorial we will be looking at spatial coordinates, which is new learning for us. Okay. Now, I've often talked about space in the classroom, and when I do I often say that space is 3D, of course. It can go up and down, it can go left and right, and it can go forwards and backwards. But if we want to find any point in space, we must have a reference from where to get that. And then we must use the axis to find it. So we might come in on the x-axis, as this sketch is shown here, up on the y-axis and out on the z-axis to find that point in space, point K in this case. Now what we'll be looking today at is 2D laminar surfaces, and they will be mainly based on triangles. They'll have 3 points, and in such questions, and you can get planes of course with many different points on them, 4 or 5, but in the ones we're doing today they're going to have 3 points, A, B and C. Now the very important thing is you have to remember when you go at these questions is that the first number is telling you to come in from the left, the second number is to go up, so this will get you the point in elevation, and the third number is to go down to plane, and this will get you your point in plane. Okay, now I'm going to draw in this datum line today, okay, on the left hand side here, but usually when I am doing these questions I just come in from the left hand side of the page. So I just grab a blue color there. Now let that be our datum line there. Okay, and so I'm going to go then, and this is usually the way I do it. Put down with that square like so. A is 46 in, and I'll just do a small a for the moment. B is 96, small b. C is 115, small c. And then I'll put in vertical lines. And then now I will go, and I know A is up 31. So there's A, up 31. Capital A now, down 61. Capital A. And then I do B, up 63. And down 12. He is up 10. C. And down 31. And then we'll join them up there. So today we're getting used to using these spatial coordinates, and we're drawing in our laminars. But the second thing is we're going to do now with this one is I want to see an edge view of this laminar. Okay, now let's finish out that line. We'll say take this line for example, look in at 90 degrees, do an auxiliary, get the true length, and then look along that line and see the plane as an edge view. Okay, but a handier thing to do would be just to take a level line across here. You could take it anywhere. Why not take it at A? It's usually the point in the middle they take it from. Now that we know where A is down in plane, that's why it's handy to take it from there. Drop that down to BC. I can draw in this line now. This line is a true length line, because if you have a line that's parallel to the XY line, then in the opposing view it must be a true length line. So, and the other key point of, or a key principle of geometry is if you want to see a plane as an edge view, you must have a true length line and look along it. So because we have a true length line now, we can look along this and we can see the plane as an edge view. Set up our x1, y1. Now C was up 10. And I'm going to go for B now. B was up 63. Now I don't bother marking off A because when I draw in this line now, which is the edge view of that plane, A would have to be where it cuts that projection line. Okay, so it saves you measuring off that guy. So that's our edge view now, which was our goal with that question. Okay, so we're going to do one more. This time with this laminar, I'm going to want to find the true shape. So again, we'll set up a datum line to measure off. And we'll keep it as close over here as we can. XY. And now A is in 34. B is in 67. C 109. And now I'll do my vertical lines. Now A up 34, down 7. B up 9, down 9. And sorry, no, A should have been down 30. Oh, it's down 7, that's right. And C up 45, down 37. And we'll join them up again. Now we'll do the same thing again. To save us taking an extra auxiliary, we'll take a level line. Drop that down. And that's our true length. So now we can look along that true length. And we can see this plane or laminar as an edge view. X1, Y1. New view, 1 views back, 2 views back. So it's up here we get our height from. And C was at 45 there. And B was at 9. So this now we get as an edge view. Of course A was there. Now we want to see the true shape of that. That was what I said was our goal for this one. So you want to see something as its true shape, you look in at 90 degrees there. Now I'll keep the XY line tight on this. X2, Y2. So new view, one view back, two views back. So we're measuring back here. So maybe get them distances there. Let's see. Get the distance of A finally. And now, so this guy is the true shape that we are after. And you can color in them if it helps you visualize it. But so I suppose the key things we got today now is, one, we're coming across spatial coordinates. So what are they? They're points in space. They have to be referenced off somewhere, okay? And the key things to remember, as we said, is in for the first number, the second number you go up, and the third number you go down to get your point in plan view, okay? So that's that video, folks. That's an introduction to oblique planes. Now we'll be doing double oblique planes after a while, and then we're going to be looking, of course, relating back to our last video, finding the dihedral angle between planes or surfaces in space, okay? So I hope you found that video useful, folks. More videos to come. Take care and stay safe.